Okay, we are on. Okay. Welcome to this presentation on Xtend, which is an Eclipse project you will learn in the next 30 minutes about. My name is Sven Efftinge, and I have with me
Sebastian Zarnekow.
And we both work for a company called itemis. We are based in Germany, and we are more or less like the JetBrains for Eclipse or so. So we build IDEs based on Eclipse for customers. We don't sell products. And so we have built this language, which is an Eclipse open source project. And it basically, it's a statically typed programming language which compiles to Java source code. So that's the first difference to other JVM languages, maybe. The idea behind that is that it really lives in the Java ecosystem. So it's not a language which will spawn a new ecosystem, including libraries and everything else, but it should really reuse what's there, what's good about Java, the library, the people, the knowledge about the JDK. And in order to really integrate nicely and have 100% Java interoperability, it's necessary to don't change the type system. So otherwise, you will end up with interoperability gotchas. And so Xtend really uses generics and primitives and all the stuff you know from the Java language as well. On top of that, of course, Ide support for Java developers is very important. I guess the IDEs we have in Java land are the most sophisticated for any language, and we need that because Java is so verbose. It forces us to repeat ourselves over and again. But there are other aspects to the tooling which are very nice, like navigation, rename refactoring, and stuff. Stuff you really like in a bit more larger projects. So Xtend comes with an Eclipse plugin, which integrates nicely with the Java IDE. Xtend it embraces functional programming. It does so by having a couple of features. One is there is no statement. Everything is an expression. Another is a very nice lambda syntax. Actually, it is very compatible to Java 8 Lambda, so it uses this target typing, if you've learned this morning, that already works with functional interfaces in Java 5. It enforces, or not enforces, but it supports final stuff by default, and you have to explicitly mark everything as a var if you want to mutate variables, and stuff like that, like list collections, for instance, or literals are immutable by default. And even more important, maybe it comes with a set of features which you can combine orthogonally to craft very expressive APIs or domain-specific languages, whatever you want to call them. And we will see some of them in the demo, which will make the rest of the talk now. So I hand over to Sebastian now.
So let's switch to Eclipse. And create a new Java project. So I call it sample, and here I will demonstrate some of the features of Xtend. So let's create a new class. And this should look familiar at a first glance because the syntax is very close to what Java provides, but we have this error marker here, which indicates that a very thin library is missing on the class path of the project. So I will just add the Xtend library.
Sebastian, maybe you want to increase the font a bit. So it's
okay.
Guess it's a bit small from behind? Yeah. Okay.
So let's...
So that's actually one of the features I miss in Eclipse compared to IntelliJ.
Me too, especially now. Okay.
Ah, cool. There's a plugin I've heard. So there's a plugin for everything in Eclipse.
So, long story short, Xtend ships with a thin library, which basically adds a couple of new methods to Java types, like Java util collection and Java util list. And we also provide Guava as a stock library just to encourage you to use it. And I want to start with a small example where I want to transform a list of strings to their uppercase representation. And I created a template for that. So let's organize the imports of this thing. And the code should look quite familiar because it's Java style. In that sense, we create a new array list with the string as the elements. We loop the parameter strings and add the uppercase representation. So you could write Xtend code as if it was Java code, but you don't have to. So first thing to keep in mind is that Xtend has better defaults with respect to the visibility of methods and fields and classes. So all classes are public by default, all methods are public by default, where fields are private by default. So I can just strip this thing down here and remove the visibility modifier. Then there are a couple of unnecessary semicolons here that I can also remove to reduce the clutter here and improve the signal to noise ratio. And there are empty parameter lists that are not necessary. If I don't want to pass any arguments, I don't have to state that. So that is not yet a very big improvement. What else can we do? So Xtend is statically typed, but it also has a powerful type inference mechanism. So I could basically remove a lot of the type information from this code snippet. For example, it's more or less obvious that the variable result will be some list of type string, and this type declaration here also more or less communicates with the compiler, but the compiler already knows what I want to do, because if I put a wrong type here, it will complain. So I don't have to tell the compiler every time that I know what I'm doing, that he also knows what he's doing. And what else can we remove? Well, the return type can also be inferred from the body of the method. So that one can go away. And last but not least, the Java 7 diamond operator is more or less omnipresent in Xtend, so I could even remove this declaration here. And it still knows that the variable result is a list of strings because I only add strings to that list. Last but not least, I could use operator overloading here rather than calling the add method. So let's just call plus equals s to uppercase. This is already more concise than the Java-ish version, but Sven mentioned that we encourage a functional programming style, and this list of expressions is not functional at all. So let's just remove all that stuff and do it the Xtend way. So we have this Java util list of strings, and what we actually want to do is we want to map all these strings to their uppercase representation. So why can't we express that? Well, we can. So even though this is only Java 7 on the class path of this project, we'll see a couple of methods that are not present in the Java 7 list implementation. Among them are some higher order functions like map. So I can invoke the map operation on Java util list. And I want to transform the strings, well, still to uppercase. And that is a lambda expression in Xtend. So the most verbose lambda expressions that I could write in Xtend. But again, we have type inference, and we know that we have a list of strings, so we most likely want to perform some operation on strings. We could skip this one. And another thing that is very interesting to see in Java APIs is that many SAM types, many interfaces with only a single abstract method, have a method that only accepts one argument. So we could also skip this one here, because the name can be synthesized by the compiler. And last but not least, if you name a variable in Xtend, it can be used if it was named this, so I don't have to repeat the receiver of the method invocation. I could even drop that thing here. And if we compare this implementation to what was written previously in this Java imperative style, that is really concise and down to the metal what we want to express. So let's invoke this method. I will add a main method here and say to uppercase for a list of strings. You know what's coming. And obviously I have to print this thing, otherwise I won't see the effect. So I invoke println. Println is not like built in or baked into the language. It's defined in this Xtend library here, and it's basically system out println on steroids, so I get the value back that I printed previously, so I can nest it in other expressions. And now I can run this thing, and it will print the result of the operation. So it's hello world. Oh, that's not too nice, so let's also join that stuff to make it more readable. And this join method, as well as the map method and a couple of other useful things like filter and flatten, etc., these are all defined in this library as so-called extension methods. And since they are extension methods, I can invoke them as if they were defined on the type itself, so as if they were defined on Java util_list. What else can I show you with this example? I could show you the debugging facilities, so let's just put a breakpoint here and see how this runs in the debugger. So it asks me to switch to the debug perspective and stopped at the invocation of the lambda expression. And since Xtend compiles to Java source code, and I'm quite a curious guy, I could, of course, just switch to the Java sources here to see what's happening underneath. And as you can see, the lambda expressions that are implemented in the to uppercase implementation, well, compiles to what you would otherwise write by hand, so an anonymous inner class that is Java 5 compatible and is invoked by means of the list extensions .map operation, where I pass the strings and the produced object of the function type. So I could now decide to debug the Java code or to go back to the Xtend code. I prefer the latter, so let's go back to default and continue the processing, and it will print hello world. So far, so good. But now I will hand over to you.
Okay. Is there a question so far? We might answer a question in between. Yeah, over there.
Question is about the generated Java code, which contains local variables where they are not present in Xtend. And the fact is that we rely on Hotspot to optimize those right now, and it makes the debugging experience quite smooth because you could see all the evaluated sub-expressions, for example, in the debugger. So there's room for improvements, but the focus was not on the most concise representation.
But we plan on improving on that as well. So for some basic features Xtend provides with lambda expressions and so on, there are many more. You would have to check out yourself on the website. I want to take the last time here we have to show you another feature called active annotation. It's a feature which allows you, there is this compiler which translates Xtend code to Java source code. So we as Java developers, this transformation is very transparent to us, and we can really understand what comes out of the process. So we thought it would be a good idea if a developer can participate somehow in this process easily, right? And that's what an active annotation is. It allows you to declare an annotation and also explain to the compiler what this annotation means. And this is very handy, especially in Java world, where we have a lot of items and design patterns which are full of boilerplate. I have one example here, which is the property change support class. I hope many of you know that class. There's some Java doc involved here. Is that readable? Well, more or less. The property change support class is a way to turn a Java bean into an observable Java bean. So it applies the observer pattern. You can register listeners with a bean, and you get a callback whenever there is a change. So some setter is called, right? So that's the idea. And in the Java doc, it explains to us how we should implement that stuff. So it's not just use it or call it, but you have to use this pattern. The first thing is you have to declare a field of property change support and two methods for adding and removing listeners. That's something you could put into a superclass, for instance. But then you have the property, a value, and you need a getter, a standard getter you can generate, but the setter needs to call the property change support class in order to trigger the event, the change event. And that's, of course, doable with like 1 or 2 properties, but usually you have a huge domain model, and if you want to bind that to the UI, you have like plenty of this kind of repetitive code, and you don't want to have this redundancy because next time you switch to JavaFX, the binding works totally different, and then you have to go over all that code again, right? So what we can do with Xtend is, let's say we have some library project. It's library. And in that, we first put the base class. I'll use a Java class for that. It could use Xtend, but I guess Java is better for boilerplate. So I copy this code. This code here, I copy over to this class and organize imports and also make this field protected so I can refer to that from subclasses, from generated Java beans. I will do in a minute. So now I'm going to develop an active annotation and call it observable. So it should be an active annotation. Okay. Observable. I haven't added the Xtend library to this project, and now organize import does its job for me. Okay. So that's basically the pattern you need to develop an active annotation. You declare an active annotation, and then you annotate it with add active, and here you point to a processor, which is some class implementing certain interface or using this abstract class. And here you have the ability to participate in the compilation step. So there are several callbacks for different compiler phases, and we want to participate in the do transform phase, where we get in the already transformed Java class. So you have an Xtend class, the Xtend compiler creates you a Java class, and then you get that one, and you can mutate it. So it's just like a Java lang class, but you can change it, okay? So what I do now is I will first add the extended class here to say, well, this class should really extend abstract entity, the class I just created here. I have to turn that into a type reference. Okay. Next up, I'll loop over all the declared fields. That's annotated class, declared fields. And I have some templates here which does some coding for me because I'm a bad typer, as you know by now. So I declare the two variables, the field name and the field type, and that's val, so it's final by default. Also parameters are final by default. They are always final, they cannot be mutated. And the first thing we want to do for each field is we want to generate the getter. So I'll say, well, annotated class, add a method, call it get with field name to first upper. You see, first upper is an extension method as it's brown. And that's a handy one, right? That's something we all want in JDK, but it's not there, so. And then we have a lambda expression here, where we get in that method object, and we can initialize it. So we set return type to be the field type, and the body should be this Java code, return this dot field name. And if I now go to this project here, and I just set a plain Java dependency, so this active annotation can be distributed in jar, and you push it to Maven Central and use it, and there's no special configuration for the compiler or so. If it's on the class bus, you can use it. So I have now this class here. I'll remove your code. Sorry about that. And make this class observable. So as we don't have any fields, for now it just extends the abstract entity. I can press F4 here on the class, so I see the type hierarchy, and you see it really extends abstract entity. You could also look at the generated code, but this is just that you know the tool is fully aware of all the changes you do in the active annotation. Next up, let's add some field, and you see we have a getter, okay? Automatically, because it's an observable class, and we explained that observable means all fields have getters. Let's go back and add a setter. So that's the code we need to add for the setter method. Again, the name is passed as the first argument, and the second argument is a lambda expression again, which we use to initialize the created method. We add a parameter, and then we set the body. We could also, of course, change whether it's static or final or whatever, but it has quite nice defaults, so we don't need to change them here. And yeah, that's a boilerplate you need to have for every setter in order to fire property change events. And if we go now back to sample here, we see it already has a setter, okay? And it really updates as you type even without saving. So the IDE, just as with Java, there's this dirty state level in front of what is persisted, and it all links properly and knows that. And only as soon as you hit save, that stuff gets written to disk also. So, any questions about that? Yes? What if the class has a superclass already? Well, then you should better check, right? So the thing is, you could, do, for instance, check whether it's an extended class, and you could also check whether it's of the correct type, or even transitively. You can also add validation errors. So,
could you please put a superclass at the sample? I want to see if there's an error message that I can't use this annotation.
there will be no error message. You will just override the slot. But you can check that, as I just said, and that's your responsibility, right? You can even, I could remove all the fields and turn them into methods or whatever I want. So you have full freedom. You can remove everything. You can create new types, interfaces, whatever.
And you can add error messages. So
yeah, I should do that.
You could just check, oh, there's an extends clause, so issue an error for that situation.
Is it object or null? Do you know that?
It will be object.
Okay, external clause. Oh, sorry. Whatever. Abstract list of string. So you see here there's an error marker. Oops. Does that answer the question? Okay.
There was another question? Okay.
Behind you, there was another question? Yeah? Okay, the question was whether the bracket, the square bracket notation is some sort of initializer. It's a lambda expression. And we use that as an initializer. Because, so what happens is that this add method, if I hover over it, you see it, it expects the name and a procedure 1. And the procedure 1 is a functional interface which has return type void and has one parameter of type mutable method declaration. Okay? And I could explicitly write it here, and you will see it's it, the variable name is it, and it's of type mutable method declaration. But in Xtend, if you have one parameter and you want to call that it, so you can access it implicitly, so this is just the same, it's a shortcut, it's like this. If you've been to Venkat's talk this morning, there was this mentioning of groovy delegates. This is basically the same idea, but it's statically typed. So no metaprogramming stuff there.
The question was about the parameter list. In fact, you can put the last argument behind the parentheses if it's a lambda expression, so to make the code more readable. This is fully equivalent to this variant here.
The idea with that sugar is that we can create new methods which look like statements. So for instance, with x, and then you have a lambda expression, right? So that it gets this idea of like blocks and so on. So it's a very common pattern or common sugar in other languages as well.
What about documentation, like JavaDoc? Can you generate it?
The question was whether I can generate JavaDoc.
Or something like that?
Why would you want to generate JavaDoc?
Well, in this case, you create a getter and a setter.
I see. Yet I know what you mean. Okay, in this annotation, yeah, sure. So you would just say, I guess it's doc command foo, and then if you have some method here, I should use other names maybe, and you call get foo,
and you put it on the setter.
On the setter, thanks. Set foo, whatever. You see it's there. Okay.
So it's easily possible to just move the documentation from the field, for example, to the getter and the setter. That would be the idea.
So we would have time for one last question.
Yes.
You want to answer?
Question is, what's the value of the assignment if everything is an expression? Well, it depends how the assignment is translated to Java code. That's part of the answer. So if the assignment maps to a setter method, then the value of the expression is the value of type primitive void. So basically, there is no value. So the equivalent to unit in other languages. And if the setter method has a return type, then the value of the expression is obviously the result of that method invocation. If it's a field, it's the value that was assigned to the field.
Actually, in Java, assignments also are expressions. So they return the value on the right-hand side if you assign a local variable. So people do that in while loops and so on. That style, but you can. Yeah. But there are, of course, expressions which don't return anything which is interesting, like while or for. So although everything is an expression, it kind of mimics statements. So you can write imperative code, but you can also nest if, for instance, or these things, or try catch blocks as a parameter of a function. That's quite possible with Xtend and easy. Last question, please.
So if I compile using Java C, I first have to convert every code
Okay, how does the compile step generally works? Can I generalize to that? Okay, so there is an Xtend compiler which translates from Xtend to Java. That's available through Maven plugin on Maven Central or Ant or whatever. So there's no Eclipse dependency. As soon as you use Eclipse, of course, there's also a compiler within the IDE which does that on the fly incrementally. And that's it. So it's a pre-compilation step. You just have to add the plugin to your build process.
Yeah. It basically lives in the generate sources stage of the Maven lifecycle.
Okay.
Okay,
If you have further questions, we will be around, maybe at the Eclipse booth. So we would like to talk to you. Thank you, guys. And sorry, I broke the applause. I want to show this website. And now, thank you.